Hello, welcome to another lesson. The last lesson we did systems of equations, substitution method, multiplication addition method. If you're just coming off watching that previous video, then this is not news to you. But this current lesson is about using computers to solve problems. And mainly speaking, we're dealing with computer notation today. So as we mentioned in the beginning of this unit, computers are dumb. They can't take word problems for us and translate them into equations. That's the programmer's job. So computers take your data and perform calculations to solve the equations, but they can't solve them unless you tell it how to do it. So we use computers because they can do our work for us very quickly as long as we give it the correct steps to follow. And the first component of providing instructions to a computer is actually typing the data in appropriately and correctly. So it says here, computer notation is slightly different from regular math notation. The goal is to input everything on a single command line. So if you've ever used command line, hopefully you have, everything is done, mainly speaking, on one line. So we can't do something like, for example, we can't write the number 5 over 12. That doesn't exist in command line. That would take 2 lines. Instead, we have to write 5/12. Okay, that would be the same thing. Well, for example, we can't write 5 to the power of 2. That doesn't exist because that subscript and superscript, I should say, superscript doesn't exist on one line. So you need to use shift 6 or caret or the exponential indicator here to say that we have a power. So very important to say we have no subscripts, we have no superscripts, we have no fractions. And we definitely don't have square roots either. We can't use the root symbol generally to write down something like this because the root, that doesn't exist in command line, at least not in your DOS prompt or something like that. You would have to use square root, and usually you put a bracket and put a 9 there. And it's very common to pronounce this as squirt, which is just a really hilarious opportunity to be able to use the word squirt in math class. So squirt stands for square root. So let's move ahead and see how this is going to be useful for us. Write the expressions in computer notation. So you can pause the video and try these yourself, but I'm going to work through them. The first one, 5 divided by 3, we have to use 5/3. That's the most common way to denote division or fractions in a computer. 5 times 9, it's actually going to be 7 asterisk 9. And asterisk would be shift 8. Just like slash is slash, asterisk here is shift 8. So it's a computer command, it's a keyboard command. 4x, well, you need to force the computer to know that you're multiplying. You can't just write 4x, okay? It doesn't work like that. You need to force the computer to understand that it is definitely a multiply. So it's going to be 4 asterisk x. So there must always be an asterisk where multiplication is performed. 1 over 2 x plus 5, well, we would have to write, let's try writing it as we see it. 1 over 2 x, well, I'm not going to have a cursive x, so it would be command line x, plus 5 is what we would expect. But the 1 over 2x is a bit of a problem. We want the 1 over 2x to come first. We want to force it to be 1 over 2 and then multiply it by x. And whenever we want to force an operation, we need to use parentheses or brackets. So read this. Without the parentheses or the brackets around the 1/2, it will be unclear whether or not the variable is meant to be included in the denominator or not. And the next problem is going to make this very clear. So in the next problem, we have a similar situation, 1 over 2x plus 5. If you didn't distinguish between this, the computer would kind of just try to do its thing and would probably get it wrong unless you force a computer to know what you're talking about. It often doesn't do what you expect. So we have 2x here on bottom. So we have, let me move this over a little bit. We have 1 over 2x plus 5. And if you're really paying close attention, both of these problems I've missed something important. And it comes back to this third step here. If I want a multiply to happen, I need to write an asterisk. So where am I missing the asterisk here? I need an asterisk between the 2 and the x here. And I need an asterisk, sorry for those of you that are writing with pen, shouldn't be writing with pen in the math class, but 1 over 2 multiplied by x plus 5. So this is actually how this is working. So if you need time to take this all in and practice it yourself, this is the time to do it. Pause the video and just try to do those questions again. For the next question, we have 1 over 2x plus 5. So we have 1 divided by one big expression to x plus 5. And so there are plenty of computer math softwares or different math programs that will accept this, okay, as opposed to the asterisks. Depending on the program, if you're dealing with like Wolfram Alpha or Desmos, for example, it will know what you mean. But in a computer, in the strictest sense, a computer often does not know that you need to multiply them together. So it's a good idea to add it in yourself if you're not sure. You can always add it in and the computer will be able to handle it. But if you leave it out, the computer may not know what you're dealing with. Okay, so just be very clear here. If in doubt, use an asterisk, I guess is my point. When you have fractions, it says here, without the parentheses, without the brackets, it would not be clear that the first x belongs inside the numerator or that the 5x plus 6 belongs inside the denominator. What the heck is it talking about? Well, let me just write it as I see it. X plus 2 divided by, I keep using the cursive x, x power 2 plus 5x plus 6. I'm leaving the asterisks out here, but I'll add it in just a little tiny and sneaky. That is not clear to a computer. If you just were to take this and give it to someone as an instruction and say, can you write that in regular math notation as a written expression, could you do it? Well, you'd get a whole bunch of different answers. Some students might go x plus 2 over x squared plus 5x plus 6, for example. And that's not what you wanted at all. That's not that. But a computer wouldn't know the difference, and certainly another person you're talking to wouldn't necessarily know the difference. So you need to force the brackets to separate the expression the way that you want it. Okay? And that's why the parentheses or the brackets are so important. So we can see that the top should be considered as one big bracket. Okay? You can almost think of the top and bottom as their own sets of brackets. And if you think of it like that, you're going to have very little trouble separating this out. So the top, we can put our own brackets in. The bottom, we can put our own brackets in. And there we go. In this case, there was no need for brackets because it was obvious what was on top and what was on bottom. But as soon as you transfer this information into a computer statement, you need to force the brackets to tell someone what we're doing. Okay, so hopefully you see what I mean. And you can try these from scratch, right? And see if you can get them. Let's move on to the next set of expressions. These are a little bit more involved. I'm going to go through all of them, but I'd like you to pause the video here and try to make sense of them yourself. See how far you can get, and then when I put the answers up, you can compare your work to mine and see how confident you are with this. You know, on a scale of 1 to 10, 10 being the best, where do you fit on that scale, okay? So let's get started here. In this first case, I'm going to treat the top like a big fraction. I'm going to treat the bottom like a big fraction. And I'm actually going to be treating the top and bottom of this almost like their own fractions so that I'm extremely clear. And some notepads that you use, for example, if you were to use Notepad, I believe it's called Notepad++, if you were to write these statements in that, it would help you match up the brackets. I think there's a color coding method that it uses. But we don't have that color coding method right now, so let's just write out what we have. We have, let's see, x plus 3 divided by 5 divided by x minus 4 divided by 2. And I've still got these bad habits. These x's are not supposed to be cursive because computers don't deal with that in a command line. And now I have this giant confusing expression that I just wrote as I saw it. So my brackets need to come in and kind of save the day here. So x plus 3 should be separate from the 5, should divide the whole top by the bottom, and I had this in brackets. That whole thing is divided by x minus 4 divided by 2. And I know my x minus 4 has brackets, and the whole bottom expression should also have its own brackets. So just bear with me, I'm going to try and shift this over. Yeah, so you can see it better. And this is all divided. All right, so I know the color coding might be slightly confusing at the moment, but something to keep in mind. You don't need to write it with colors, of course. The colors are for you to understand it. But as long as you have brackets that all match up, I'm not too concerned. Just whenever you open a bracket, remember that you're going to have to close one later. So let's look at the little note here. It says, using multiple sets of parentheses or brackets to demark the two fractions within the complex fraction. That can be very useful. And then it says, using extra spaces is helpful too. So sometimes when you write it on a command line, if you're a little confused as to what's going on, just add extra space with the space bar. So speaking of Notepad++, I just downloaded it and opened it up here just so that we can have something to look at. So you can see what I mean when I'm talking about this command line stuff. So I don't like to use command line as much because it's not as color coded, but when you're doing computer notation, it can be really helpful to see this stuff. So I'm just going to type out what I wrote here. So the way I think about this is I have a big fraction on top divided by a big fraction on bottom. I like to start it that way. And then the big fraction on top is x plus 3 over 5. So I like to set up a bracket, x plus 3 divided by 5. And I know that my top expression is handled. I can check the brackets, I can see that everything works out. On bottom, in my big fraction on bottom, I have x minus 4, so once again brackets, and then divide that by 2. And I know that that is the final expression that I'm looking for. All right, so that's what it's meant to look like in computer notation. X squared, that's a pretty easy one. It's just x power 2. We just use the caret. So that's x shift 6, 2. For the next one, x power 2 over 3, some students are tempted to do this, which is not necessarily obvious. The computer might think that you want to do x to the power of 2 and then divide that by 3, which would end up giving x squared over 3, which is not the same, of course. So you need to force it to understand you. You should put brackets over the 2 over 3. And so in this case, it would be x to the power of 2 divided by 3. All right, so hopefully you can see what I'm getting at here. In the next case, x to the power of 2 multiplied by y power of 3. I've already messed up. Oops. I need to remember that there are no superscripts in a computer, not in command line. So this is multiplied by y power 3 multiplied by z power 4. Sometimes I confuse myself. So it says there must always be an asterisk where multiplication is performed. And that's what I've done here. As a command line, x power 2 multiplied by y power 3, multiplied by z power 4. And in some rare cases, it might actually get this confused. It might think it's x power 2 times y. So it's actually a good idea to add in brackets. If you're ever not sure that the computer is going to know exactly what you want, you should put in your own brackets to make sure that it's doing what you want. Okay? So there's never such thing as too many brackets. There is definitely such thing as too few. In the next question, b power 2 minus 4 multiplied by a multiplied by c. And it says, once again, you need asterisks. You need the star whenever you have a multiply. So once again, b power 2 minus 4 times a times c. Very important that you understand this one. This is part of the quadratic formula, right? Very important to know. In this case, there's no real need for brackets, although if you're going to put some, you'd probably want to put some in front of the b power 2 to make sure that the b power 2 comes before minus 4ac. In this case, we have square root of 2y. Well, we can't just use the square root symbol. It's not appropriate. We should really be using squirt, square root. So we should say the square root of 2 times y. And once again, that is not completely clear whether or not it's doing square root of 2 times y, which would be root 2 times y on the outside, which is not what we want, or, is it going to include both? And we definitely want to include both. So our brackets are extremely important here. We need to add them in and make sure that it's grouping, it's doing the square root of all of that stuff under the brackets. So once again, squirt of 2 times y. And that's how it's going to look like in a command line or on a computer. All right, so that's how we deal with getting our written expressions in math into computer notation. So the next page involves a bit of practice with this, and the solutions are online. You can check them. If you have any issues getting the answer to any of these, just let me know. Make a note of the slide number. Tell me the number of the practice that you have trouble with, and we'll go through it together. But I want to show you that you can check your work using either Desmos or Wolfram Alpha, and often Wolfram Alpha is a nice one. So let me just show you. I'll just take one of these. For example, in computer notation, 5 times a to the power of 3 is 5 multiplied by a to the power of 3. All right, so that would be that one. Let me actually take one that I did in the command line, because that'll be more useful. So for example, let's just say we typed this out as an answer, and we wanted to check it in Wolfram Alpha, because you're going to be doing this stuff on a computer. That's the whole point. So you can take your statement. You can do this in a regular notepad. Take your statement and go to wolframalpha.com and just paste your statement in. You can even go and pick through it with your arrow keys, and it'll tell you which brackets are relating to what. So you can double check that everything is as it should be, and then we should evaluate this and get back what we expect. If you've given it the proper instructions, it'll give you back the proper expression. And that is exactly what we started with. If you go back into the notes and take a look, x plus 3 over 5, x minus 4 over 2, we get that exact expression. Let's just say we really messed this up and we didn't use brackets at all and decided that we just wanted to live on the wild side and see what it would give us. Let's see what Wolfram Alpha does with it. Okay, see the importance of adding your own brackets? It makes a huge difference. Maybe you just put some brackets in here because you're like, well, Mr. Scott said that I should put brackets in. Let's see what I get. Maybe we'll look into the right thing. No, that's even worse. So proper documentation, proper notation, computer notation is extremely important. In fact, it's crucial, or you're going to be spitting gibberish into the computer, and garbage in equals garbage out, right? That's a classic rule of programming. If you give trash for the computer to work with, it's going to give you back trash. So something to keep in mind. You can check all these answers on D2L, like I said. The next section, or the next practice, is just writing in written notation, and that means converting back to regular notation. And you can check these in Wolfram Alpha as well. But let's just see if we can do the first one. 2 times x times y minus z power 3. So that's just 2x, y minus z power 3. So it's like a breath of fresh air being able to use our regular math notation again. We know that these are multiplied. There's no need to write in our multiply symbols anymore. We know that this is a superscript, and so we don't need to write in our power. It's nice. It's good going back the other way. I'm just going to take this expression here, 2 times x times y minus z power 3, and see what I get in Wolfram. 2 times x times y minus z power 3. Make sure that Wolfram Alpha understands what I'm talking about. And yeah, this is the mathematical expression that we're expecting. So that's the written notation here. So you should really try this yourself, and you can check your work with Wolfram Alpha to make sure that everything's going according to plan. So that's it for the computer notation section of this video. The next section of the video is actually just me introducing a small reading assignment, which is what you should do on your own time. I guess everything's on your own time right now, but this is literally a reading one. So it says read the associated module on D2L. The associated module is the one that's called working with data. Okay? It says you'll be expected to understand some key information from this section for your assessments, mainly your assignment, maybe part A, part B, or possibly even on a test. All right, it's going to come back at some point. So when you're finished reading, you should at least be able to do the following. State the conditions for writing a proper assignment statement. So you're going to learn what an assignment statement is, and you're going to be able to state the conditions for writing that statement. You're going to be listing some of the most common data types. For example, integers are a data type. And then you're going to have to be capable of taking basic written statements or problems and converting them into assignment statements. And the problems that will come along with this, the practice that will come along, it says determine whether the statement is a proper assignment statement. You'll learn, for example, that the first one is and the second one isn't, because you always need to initialize your variable on the left, and then it will save the number on the right or the expression on the right in that box. So I like to think of it as some sort of mysterious X box, which can hold any information that you like, and we're telling it that we have the number 2, and we're going to save that in that box. And we've assigned X to be that. Same sort of thing here. We can assign full statements and put them in the box as long as we initialize every piece. So this is what you'll learn in the assignment. In practice 2, it says determine the correct data type. So you'll need to learn about what data types are, and then you'll be able to classify these. So I'll let you try that yourself in the reading assignment, but you'll learn that, for example, this is a different data type than false, of course, because there are 2 different types of data. All right. So again, I'm not going to try to over-explain that. I want you to do that yourself. I'm just showing you the problems. Finally, in practice 3, it says write a computer assignment statement. So that means that you're going to have some sort of variable, usually, equals some sort of computer notation. This is where your assignment is going to be, what you're assigning to that variable, whether it's an expression, equation, or so on, and it gets saved as that variable. So again, you're going to understand this more when you do the reading assignment. In fact, I probably should have recommended that you do the reading first and then listen to my explanation here. But in any case, the answers are on D12, and if you have any questions on it, please note the questions you have trouble with, and we'll go through it together. That's it for this video. I'll see you again in the next class, the next live class, and I wish you all the best.